is over. Let's shift to the actual real webinars. So good morning, good afternoon, good evening to the folks that joined just more recently. Apologies, we started a bit early, technical error, and we decided to do pre-game webinar, which I think is definitely something we're going to do more in the future, Michael. That was a lot of fun. So welcome to the second Custom by Veeam webinar. We call them the KubeSeries, and we're planning to do one every month this year, and probably beyond that as well. I'm Tom Leyden. I'm VP of Marketing here at Custom by Veeam, and I'm going to be your host. So I'm super excited to have Michael Cade, our Senior Technologist at Custom, here with me. This best practices for Kubernetes data protection webinar is going to be a very, very strong one. And it will help you to dive into Kubernetes with confidence. Michael will prep you to navigate the data storm. And I'm personally very much looking forward to the demo and also to learning how to do backups with object storage and make sure they are ransomware resistant. So that's going to be really, really interesting. Before I hand it over to Michael, a few practicalities. Everyone except Michael and myself, even though I will disappear, will be muted, but we still want this webinar to be very interactive. So anyone who has questions, please use the Q&A. You're okay to ask questions in the chat, but for us, it's a little easier to follow up on what has been answered in the Q&A box. So if you have a pressing question and you want to make sure it gets our attention, please use that one, even though we're also monitoring and participating in the chat. Let's be interactive. Love all the messages that I've been seeing already. I see a person joining from Kenya, one person from Mexico, one person from India. Really international audience. So thank you all for joining us. I believe there's also some polling questions, and those really help us understand where we need to take those webinars, how we need to progress, and how we need to tweak our webinars in the future. So it would be great if you could answer those. And finally, but not unimportant, to thank you all for making the time to participate in this webinar. And participating is really the key word here. We want this to be interactive. There is a raffle at the end of the webinar. And the raffle will be held with folks that are still present on the webinar. So we really want folks to be here for the entire webinar, which makes a lot of sense, I think. The raffle is a $200 Amazon gift card, so that's pretty awesome. So one person will be getting that at the end of the webinar. Oh, one more thing. I already saw someone ask it. The webinar is being recorded and we will make it available afterwards. So expect a short email after the webinar where we will provide you a link to that recording. Experience tells us that we're probably going to have more questions than we can answer. So we're probably going to use that email to address a few questions if we haven't had the time to answer them here. Michael loves blogging, as you may have heard. So one option would also be to take a few questions and address them in a follow-up blog article. So please do ask your questions. Now, without further ado, Michael, you want to kick it off?
Yeah, absolutely. I think I'd just echo one more thing there on that, is that like the feedback is super important to us. So it's all well and good we can put on these, we can get nearly 300 people in the room, but being able to get your feedback about whether it's hitting the right topics, right areas, that's super important as well for us, right? Because everyone's on a different learning journey, different angles, different places. It's about being able to help. As long as this helps the majority of you out there, then that's really what we're after. But yeah, let's get into it. The other thing that I'll mention is that from a social media point of view, so at Michael Cade 1, I'm generally lurking around there most days and nights. If there's any questions, ping them there. You're generally going to get a quicker answer there than you are from an email. But also LinkedIn, basically anywhere is a good place to have those questions. I want to be able to really help from a Kubernetes data management or cloud native data management story, and what it is that we need to consider when it comes to this. The other thing that we'll add into the email, the blast out email after the fact, is not only the recording, but I believe there's a white paper that goes very, very well alongside these 5 best practices that we have as well. So with that is that I want to really kick things off about Kasten. What it is we do, what our mission is, what our swim lane is, where we're staying, and what we're really doing in that Kubernetes space. And then, spoiler alert, these might be the 5 best practices that we're going to get into. One is, what does the architecture look like when it comes to Kubernetes, or what should we consider when we're thinking about protecting our workloads or having a data management solution around that? Then, obviously, from a backup or data management point of view, we want to have some level of recoverability. So we're going to talk about what we should be looking for, but also what we should be considering. Operations, how do we have visibility and observability into our everything that we're doing within our clusters? Security, obviously, this is topical across any platform. Everyone's talking about ransomware, and like Tom said at the end, I can flip to a recorded demo to show some of the features and functionality that we have within Kasten K10 that highlights some of the areas, especially around ransomware, where we can help with Kasten K10. And then probably something that is not necessarily on the cards today for you, depending on where you are in your Kubernetes journey, but we strongly believe that portability is going to become a huge factor, because being able to move that application and all of its data with that from one cluster to another is becoming more and more of an ideology of being able to quickly move between different services, but then also being able to present that data in a different cloud and take advantage of different services that cloud may have to glean information from that data. And then wash it away, get rid of it, because we only want a copy of it whilst our production is still running. But instead of me using this slide to talk about that, we'll obviously get into that as well. So really kicking off with talking about Kasten K10, what it is that Kasten in general are really focused around, as well as being part of a broader company in Veeam, where we're concentrating on protecting workloads across all platforms. Kasten has a much more defined outlook as to and vision and strategy about where and what we're protecting. So in terms of about Kasten, our mission is obviously to tackle those day 2 data management challenges. If you've seen any of our other webinars, we might have spoken about day 0. And again, depending on where you are on your journey around Kubernetes, is that it's overwhelming, to say the least, as to how that day 0 looks about where you decide to deploy your Kubernetes cluster. There's obviously an overwhelming amount of different places that you could deploy it. They could be managed. I also mentioned before that you can roll your own on premises, but really our swim lane resolves in these three areas. The first one being backup and recovery, and I would say that this is our most common communication point with any prospects customers today, is how do we protect and how do we recover workloads that reside within Kubernetes. I would also say that secondly, we have that disaster recovery, and in particular around automated disaster recovery. How can I make sure that those applications are available to me, or at least in a warm standby situation in another cloud or in another Kubernetes environment somewhere else, that I can quickly hit a button and have everything fail over in an automated way and bring it up in that secondary location. And then the one that I mentioned before that I'm going to get on later to is around portability or mobility of our application. How can I take that application where it's running in Kubernetes cluster A and move it to Kubernetes cluster B? And that could be OpenShift to EKS, or it could be EKS to OpenShift, or on-prem Kubernetes. Really, from a custom point of view, being software only, with no storage requirement, it gives us the flexibility of being able to move our workloads quite freely. And I'm going to touch on some of the terminology around transformation and being able to change what our application can look like in a secondary place. And just like diving down into some of those bullet points is, well, what do we mean by backup and restore? Because so Kasten K10 is deployed within the Kubernetes cluster, which opens the door for us to do a lot of things. It basically means that we live and breathe the same Kubernetes API, and we can be consumed by that Kubernetes API, which then means that we can hook into existing multi-tenancy, so different authentication methods. We can roll into our role-based access control. We can scale our workloads accordingly to protect the workloads, as well as being able to help in terms of moving that data or restoring that data in whatever scale or whatever amount of scale that needs to look like. as well as performance. And then probably the key part to that backup and restore kind of goes to what I just mentioned around polyglot persistence, which is generally around being agnostic to the Kubernetes environment that we're protecting, but then also where we can recover to as well. So this could mean Kubernetes rolled on premises, but it also could mean any of the major cloud providers. It could mean any managed Kubernetes cluster. From a disaster recovery point of view, the ability to just have another version of that data in a different location, just in case failures do happen. And I spoke about in the pre thing to the webinar, we were talking about where and what are the biggest headaches when it comes to rolling out Kubernetes, and what are the challenges. And one of the things is having that overwhelming amount of choice when it comes to Kubernetes platforms. But on top of that, we want to be able to move our workloads and have that be covered for any failure scenario. But I also mentioned that it's the same but a little bit different to previous platforms such as virtualization and cloud-based workloads, in that we can easily have that copy of that data there. So having a copy of that data in any of those locations, and I start to mention things like storage transformation, being able to take it from one storage class to another and vice versa, whatever that needs to look like in that secondary location. And having that already happening as a scheduled policy so that you've got a copy of that data, maybe a scaled down version of your application running in a warm standby type mode. And then as and when, or if a failure scenario was to happen, you can click the button and everything comes up as part of your failover plan. And then more and more in the Kubernetes world, in comparison to like virtualization, is that we have the requirement to have to upgrade our clusters quite frequently. Kubernetes releases generally 2 to 3 times a year. So we want to make sure that we're on that latest and greatest version of Kubernetes. So we might be lifting and shifting and upgrading our clusters quite frequently. So with that, we also maybe want to move our workloads, or maybe we don't even care about upgrading our cluster. Maybe we just build a new one and migrate everything over. Like actually thinking about different ways of being able to provision these, because do we really care about Kubernetes nodes anymore? Do we really care about what they look like? Or do we just want them to be on the latest and greatest version of the software? And then that then leads to things like application transformation. How do I manipulate that code so that I can leverage that in a different location, but also so how it looks, and how can I potentially leverage that application in a different cloud to take advantage of some of the specifics in something like Google Cloud, and using some of their BigQuery against my application, and then throwing it away from a data mining point of view. And then obviously test and dev clusters. You can really use the full suite of Cast and K10 to be able to take a copy of your data, clone that data to a different cluster, let it be used by developers to maybe test new features and functionality against that data. Data scientists on the call that there were at the very beginning is being able to take your algorithm and use that test data and clone that data so that you can constantly be using your algorithm against that. So from a Kubernetes 40,000 foot view, is a fast growing infrastructure. Obviously, we would have those on-premises servers that I've already mentioned. Then we had that shift to virtualization, none of which have gone away. And we're definitely not going to come on here and start to say things like containers versus VMs. They're a completely different object within where we run our application. However, we're seeing that huge shift to containerization and then into Kubernetes as a container orchestrator. So that shift has happened. And really the key part there is that the shift to containers have been around a lot longer than pre-2000s. What actually made containers a usable feature for the majority of us out there is actually the not the container technology itself, although Docker did create something that was very usable. It was the container image and the image libraries that we see today in Docker Hub, but also in other repositories out there. And then that spawned a requirement to be able to scale and have more control and orchestrate those containers within a platform such as Kubernetes. So obviously I've mentioned quite a few times about how this is growing exponentially, and this is from IDC. In fact, this is from IDC, Gartner, and ESG, so all of the major analysts, and you can see what the forecast looks like. So if we think that we're already moving quite quickly in the direction of cloud native, you can see here that we can, like, 500 million new apps will be living in a cloud native environment such as Kubernetes, and that's more than the last 40 years all combined. And then another big thing, 75% of enterprises running some sort of containerized apps. I actually believe we'll get there before 2025, but I won't mess with the analysts. And then the IT organizations needing dedicated solutions to protect that workload. But think about that. It's not just backup tools, but think about that wider ecosystem around data management. How can I leverage tools to do more than one job? Application transformation, application portability, data backup and recovery, disaster recovery, all in one tool set is really the key angle there. And then being able to integrate that into other and future platforms is another key part. So what are we seeing from a market growth point of view? Or what are we having conversations about? One is infrastructure transformation, like Kubernetes being available everywhere. Again, I've said that more than enough times already today. Also, we're seeing a massive influx of hybrid cloud environments running Kubernetes both on premises, but then also in the public cloud. And how do we manage those all together and have the freedom of choice when it comes to where we're running those workloads? And then probably the biggest change over the last 5 years has really been about stateful applications, being able to really hone in on and use Kubernetes to run our databases and take all that advantage of the scalability of that, whilst being having that advantage, whilst being able to run and keep our database serving data to our users. So what are the key asks when it comes to data protection? One, it has to be Kubernetes native. I touched on K10 being built into the Kubernetes API as part of the deployment. Another key part is that freedom of choice, both of which I've spoke about already, probably more than enough. Another thing when it comes to data management, and this is really across any platform, and this is probably my Veeam hat on, is that consistency really does matter, especially when you're talking about stateful workloads. You might not need consistency if you're just protecting a web app, a web server, or a web container. But when you start pushing things like data services into that, like a database, like a messaging queue, like a batch processing, login metrics, etc., then you're going to need some way of being able to coerce that workload so that you can have a copy of that, so that when you come to recover it, the data is in a good state. And then kind of goes back with the first one, is being able to integrate into your automation workflows, whether that be your CI/CD pipelines, but also being able to leverage that automation. You leverage that API. Not everyone needs a UI to from an operations point of view, but being able to really automate some of those tasks around data management. Okay, so now we get into the actual best practices. So the first one is architecture, and this one is key in that the focus for anything Kubernetes has to be on the application. The whole premise of Kubernetes that we haven't got time to really dive into is very much focused on the application. Now, that application consists of multiple different microservices and different artifacts within your cluster, and something similar to what we see on the page here. But what we need to do from a data protection point of view is be able to capture that all in a consistent manner, so that we can, one, protect everything that we have in our application, but also be able to recover everything in a consistent manner, so that it's actually going to come back up when it restores. Sorry. So the key thing here, and I'll touch on a bit of the K10 architecture, because I think it goes hand in hand with what I've just mentioned, is that K10 itself is natively deployed inside of your Kubernetes environment. It's agnostic to whatever that virtual or that physical infrastructure looks like underneath, having integrations into VMware, into public cloud offerings, Google GKE, Microsoft AKS, Amazon EKS. as well as OpenShift, which can be run pretty much anywhere. But ultimately, from a K10 perspective, it gets deployed in its own namespace in your cluster. And then from there, that's what gives us that native Kubernetes API. So we live and breathe inside that native API. And then we do have the ability to hook into infrastructure APIs. Now, we leverage things like CSI as a driver to be able to take those consistent snapshots, but then also being able to store our backups into object storage, but also sometimes, especially in the public cloud, where we have partner integrations into EKS, into GKE, for example, to make sure that we're taking the most fast and efficient backups from that point of view. And then finally is the application layer. So the application framework I mentioned around like having a database that is more often than not, I think CNCF survey says around over 50% of clusters out there, Kubernetes clusters out there, are running some level of stateful workload, which is testament that people are running stateful workloads in Kubernetes. But in order for us to make sure that we're taking a clean copy of that, an application consistent copy of that, is that we must be able to speak the language of the application. So things like in Postgres, for example, Postgres have a native tool called PG dump. How do we call that and leverage that as part of our whole combined way of being able to protect that workload? Now it's optional because we might also be just protecting a web server. We might just be protecting something along them lines. But from a Postgres point of view, we have the ability to create these application blueprints that hook into the data service itself and be able to protect that and store that into object storage. So recoverability is obviously massively important. Architecture is key in terms of where we are. So I kind of liken this to how Veeam started protecting workloads, virtual machines within VMware, because traditionally any backup vendor was outside of the virtual environment and they were looking in and they were using agents to begin with. They were using the same agents that they would protect their physical machines with, and then they would use those agents to protect virtual machines. Along came Veeam and they hooked into the native vSphere API to be able to pull out that data more efficiently, faster. In a similar way, that's exactly what K10 does from a Kubernetes point of view. It is deployed within the cluster. It enables us to pull out that data in a more efficient manner, but with all the benefits of not being tied into having an underpinning storage layer. Like the key part there is to being agnostic to that. The other part is another common question that I get around the architecture here is that obviously that's a design principle that we made from a custom engineering perspective. But importantly, we also have built into the K10 platform is the ability to automate that disaster recovery or that catalog, the important part, off into another cluster as well. So if you were to lose the whole cluster, that doesn't mean you're out. It means that we've just got to fail over and use a different cluster to restore the catalog, which is where all the important information is around your backups. So recoverability, I mentioned around, okay, architecture, great, fast, efficient way of being able to protect our workloads. We live inside the Kubernetes API so that we can live and breathe that and be leveraged from an automation point of view. But from a recovery point of view, there's two areas that I want to touch on. One is the backup and restore. So clearly we want to be able to restore to a known good state of our application. But it might be that we also want to restore badly misconfigured user error type mistakes that happen still in Kubernetes. Remarkably, accidental deletion will still be one of the biggest areas that we have to contend with when it comes to Kubernetes and data management. For any database, and I would say as well as any database that is replicated or non-replicated, we still want to have a copy of that, because in a database that is replicated maybe across site, across different regions, geos, etc., there's still an element of risk where you could incorporate or insert failure or a misconfiguration into that database, and then suddenly it gets replicated between. By having a backup of that before that happens, that gives us peace of mind to know that we can spin up that environment. And the other side, and this bottom one kind of goes into the requirement around being able to clone our workloads and give it up to another service to glean information, or potentially off to a developer team to test out new functionality, or even to be able to give it to our auditors so that they can look at what data we are storing in there. And then it comes back to disaster recovery. So it's arguably, depending on what the nature of the failure scenario, that, well, any failure could be a disaster, depending on what that failure is. So I see those worlds actually combining a little, but the ability to restore all of our application components, also with a granularity to that, into a completely different Kubernetes cluster, could be a completely different flavor of Kubernetes as well. And being able to use a policy-based engine to be able to achieve that and get them sent off and be able to have a really fast recovery time because we've got that warm standby copy over in that secondary location. So without getting into the weeds from a technical point of view, over on the right-hand side, you see a bit of well, in the middle, you see a bit of a workflow of what happens. Is that something bad's happened and we want to be able to recover that workload. Wherever that workload may be, these take very similar routes, whether it's disaster or whether it's just backup or a recovery from a backup into the same cluster. But basically, we trigger that restore, and that creates something called a restore action, again, found in the native Kubernetes API. And from there, we start to record or restore those aspects that we need to do. We start building out the application, we start pushing the data, and then we push that back into whatever location that needs to be. We restore that back, we choose the restore location. So if we did want to clone a copy of our workload, the same recovery process would take place, but maybe we want to change what that namespace looks like or what our application is called. So we do a hyphen clone, and we can do that as well. But then also we can be quite granular. So if you think about your application being built of 10 to 100 different artifacts of different pods and deployments and other areas, maybe you only want to bring back the PVC, the persistent volume claim, which has got your important data in, and you just want to use a web browser, Mongo Express, for example, to dive into that, to be able to glean some information, create something against that, mask some of that data before giving it to a developer team. We can do that as well from that point of view. So then just quickly rattling through these operations. So this is really my background coming into the world of cloud native. I think one of the key things that you'll see already, depending on your background, is that backup recovery or data management in general is the same, but a little bit different when it comes to Kubernetes. Like, yes, we want to be native. Yes, we want to be using the best tool set to be able to move and create our backups and data sets. But really, it doesn't change any of the fundamentals, like architecture around virtual machine backup or operations around virtual machines or cloud-based workloads. Ultimately, we still want to have that visibility, that peace of mind that things are happening or if things aren't going to plan. If our backups aren't working, I need to know about that. I need to work on how do we fix that within our environment. So one of the key parts of that is the ability to create our automated policies. So set up policies based on labels or tags so that they're automatically going to grab everything that you deploy into that cluster. So you're not dependent on the application owner deploying something and you as an operation engineer or in the ops team or backup admin, you're not having to go and scour the whole place to understand whether everything's protected. You can put in fail safes that leverage labels and tags so that you can back up everything around that. And then you can define that as an SLA or whatever that SLA needs to be for that matter. And then to the point that I just made around, well, I need to be able to see what's happening. And we've actually worked really hard on this from a K10 point of view, is show visibility. This is what's happening on a day-to-day basis. Out of the box, you go into our dashboard, you'll see exactly that. You'll see the activity for the last, I think it's 24 hours, and it gives you that insight into that. Now, also, if you go into that final card, you've now got more insight and you've got the ability to move and leverage other ecosystem partners such as Prometheus and Grafana tools to be able to get more information, get more metrics out of that which then leads on to how do we notify and how do we understand that? How do we get Slack webhooks and notifications in our whatever tool set that you want based on your tool set that you have? But I think making sure that you have that capability of being able to see and hear what is happening within your environment is a real big thing from an operations best practice. And this goes, again, we can look at all of the different areas or the different segments mentioned here. So from a storage point of view, I want to have some visibility of what storage I'm using, how much, what does that change rate look like? What is the Kubernetes layer that I'm using? And especially if you're using something like Prometheus already to log your metrics, Grafana to display those metrics, we can hook into those existing tools to then just bolt on, this is what our data management landscape looks like. And you can start to see there as well, the K10 platform gives you that visibility across the park, whether it's having the ability to automatically discover applications, an easy, intuitive UI to be able to see what's happening at a glance without having to dig deep into things. However, there is an API obviously for that as well, and be able to see what is happening. Same for those data services. How do we understand or how do we protect those workloads from an operations point of view? And that's where Canister comes in from an open source perspective. There's a project maintained by Kasten, and that gives us the flexibility of being able to create those blueprints that protects those native applications. So like I mentioned around Postgres and PG dump. I think this is the fourth one, security. So security is obviously top of mind for a lot of engineers, whether they be developers, DevOps, or operations folk. And again, this goes to the point where we're leveraging the native Kubernetes API, but also being able to use those other ecosystem partners where things like authentication using OIDC or our own Kubernetes token-based authentication to gain access to our cluster, our K10 dashboard. Also, if we're lifting and shifting data from A to B, we want to make sure that that is encrypted throughout on that flight, like so whether it's at rest or in motion, making sure that wherever that's moving, it's encrypted. Multi-tenancy, making sure that we can provide self-service portals. So not only for visibility for that operations side, but also have control over specific applications. Could also be around specific clusters as well as role-based access control. I only want certain people to be able to see certain applications, and we've done quite a lot of work around role-based access control there as well. I think it's also, or it would be remiss if I didn't mention around security and containers. So one of the features that we brought out in version 4.5 was the ability to send our backups into immutable storage. Immutable being AWS S3 using the Object Lock API, but also being able to use the S3 compatible Object Lock API. So any on-premises or any other S3 based object storage that has that API, then we've got the ability to leverage that as a place to store those exported backups. But I think this is more in general, so security is a consideration in general around containers, because it's very easy to go and create a container that has God mode. It has complete root access. And in case that happens, then there's a vulnerability there in that if anyone gains access to that application, that container, then you are potentially, you could potentially be compromised to that. As well as not being kept up to date with Kubernetes releases, which is full of vulnerability scanning releases or vulnerability patches, as well as third-party tools that you might use in and around your Kubernetes cluster. And then probably more importantly, what we're seeing across the board here is having that backup and recovery gap, thinking that something is covered when it's not, or even more so, how open is that target? While by being able to push our backups into an immutable object storage layer, that even AWS cannot remove that right of that data. So that gives you the good peace of mind is that, well, once that data is in that object lock backed repository, it means that you're not going to lose that data, which is kind of important for those mission critical applications. Okay, and then finally, I want to talk about the application mobility. And this is a huge, we could literally do a whole webinar on this, because I think it's one of the coolest things that we do at Kasten, is the ability to back up and recovery, move data from A to B, is everything that we speak about today. But application mobility opens up the door for so many things within the Kubernetes and wider ecosystem, cloud native ecosystem, because it opens the door to be able to move those applications, those stateful applications, from one place to another without worrying about what that underpinning storage is. If you think about your outlay when it comes to, oh, I'm going to choose cloud A, I won't pick on any in particular. And maybe you pick cloud A at the very beginning, but after 90 days, maybe cloud A is bumping up their prices, or maybe it's just not as fast, or maybe your business is now in different locations, or maybe they don't have, or maybe you've expanded and they don't have locations in some of those places that you've just inherited. What this gives you the ability to do is quite easily move that workload from one managed cluster or a Kubernetes cluster to another without really complicating or changing too much other than the underpinning configuration. So if I was to go from Azure AKS, so Microsoft AKS, Azure Kubernetes Service, they use their underpinning storage, or one of their underpinning storage is called managed-CSI. And if I go to Amazon EKS, for example, they have GPL2. Let's use GPL2 to begin with. They also have some CSI. I can't remember the name off the top. I think it's called Premium-RWO. So two different names. So if we were to move our application in code, that wouldn't work because we'd have to change that code to reflect that, which in the grand scheme of things is not that's not the hard part. What is hard though is that potential 500, 1 terabyte PVC that we need to move that contains our database, our mission critical database. How do we move that? How do we restore that into a different location? And that's where that transformation engine comes in and gives us the ability to change what that looks like in Azure to EKS, or EKS to Azure, or literally any of those, or any Kubernetes service, including OpenShift. The other area there is for test and dev type environments or cloned environments, cluster upgrades, as I already touched on as well. But the ability there, that transformation engine, and I think this next slide kind of gives it that. Yeah, so one, it could be really useful from a restore point of view. Think about that disaster recovery, but it doesn't need to be a disaster. We just want to restore it to a different location. We don't want that process to be, and you could always argue that migration should be in there as well. Migration, restore, clone, in fact, migrate is there. Those three things are the key use cases when it comes to portability, being able to restore to a different cluster, being able to clone to a different cluster and take advantage of other services that might be available. Or actually, I'm moving, I'm migrating to a different location, whilst also having that freedom of choice, different storage, different distributions, different clouds, having the resiliency across different namespaces, being able to restore at a granular basis to be able to spin up and spin down whatever you need. And I've kind of gone through the use cases there. So this kind of gets into the weeds a little bit about the transformation. Let me build this out a touch. So if you think about where we are from a Kasten K10 point of view, in terms of how you can consume K10, either from a dashboard, a CLI, or an SDK plugged into that, then from a customer point of view, what do you want to, the visible features. So I've spoken about our policy engine, configuration, profiles are where we're going to store those backups, that S3 repository, infrastructure or orchestration. So what are we sat on? Are we on Google Cloud? Are we on particular vSphere? Also being able to leverage some of that Kubernetes native API around security. And obviously very important is the catalog. How do we store what we're actually protecting? So then from a data transformation engine, when we're sending that data off into our profiles, we're also considering things like compression, dedupe, encryption as well. And then from that transform point of view, how do we've got the ability to transform what that application looks like when we restore that in that secondary location. So whether that be external resources that are linked to that application using config maps, whether that be storage transformations like I just ran through, whether it be change from storage class A to storage class B. And that might be just a migration within the same cloud where you're wanting to use a quicker, a faster set of storage. But in general, any of those Kubernetes objects, we can change what the scale looks like. How many replicas do you want in that secondary location as part of that migration? Do we want to scale it down? Do we want to scale it up? There's a really easy user interface to be able to dictate what those transforms really look like. Okay, so before Tom comes back on and asks some of the questions that hopefully have come in, I just want to reiterate some of those key areas. So the first one was around architecture, about what you should be considering when it comes to data protection within Kubernetes, but also how K10 lives and breathes in the Kubernetes cluster. Consider about recoverability and what options you have around that. Operations, how do we have visibility, but also who has control and where. As the same for security in a way, in that we want to make sure that we can define swim lanes to our developers, DevOps, operations, QA, etc. They might need access to that API, that UI, that dashboard, but let's define what it looks like. Let's not just give God mode to everyone and a token to everyone to be able to do what they want. And then probably my favorite feature of all is, well, how do we enable that capability of being able to move freely between our environments or from one environment to another? So I think with that, I'll leave this on, Tom. Have there been any questions at all?
I was just addressing them. There's been so many. This was so awesome. First of all, I feel 10% smarter. So let's do another 9 webinars, and then I'll be double as smart as I was. I just got a question that we're probably not going to answer for real. Someone was asking about the price, and I responded that on the website custom.io, you can actually find a free version that can be used up to only 10%. That's a pretty good deal. So on Custom.io, go to free K10 and you can download a free version of the software that can be used for up to 10 nodes. So that is already a present for everybody. I think I also have a name to announce. Harold Neiman is the winner of our gift card. So let's get that out of the way. And then let's get to a few questions. So one question I thought would be interesting to address. We got several people asking about the marketplaces where we are present. Can you shed a light on that?
Yeah, you might be putting me on the spot there, because it feels like we're announcing marketplaces left, right, and center. I would say, in fact, you might be better off answering that, Tom. But I know there was one. Did one get released today? I don't know if I can even say it.
You know what? We're going to address that one in the follow-up email to that and make sure that we got it all proper. So
I think that's probably best. Like they're in flight all over the place. Like OpenShift, I know is absolutely there. I believe we're in the AWS marketplace, but I wouldn't want to go and say and spoil any other blasts that are going to happen.
All right, good. No, I'll ask the team to make a note that a little short list of the marketplaces where you can find a solution should definitely be addressed in the follow-up email to this webinar. So let's do that. Murali was asking, how can we incorporate Kubernetes backup into existing disaster recovery and backup processes?
So I'm going to assume, and please come back into the chat and ask and give us the lowdown on this. Like if we're talking about Kubernetes and you're already running stateful workloads, then K10 is easily deployed using a Helm chart. Deploy it into your cluster. it will automatically discover your existing applications, add in your profile, as in add in your export location, AWS S3, but we also can go to Google Cloud Storage, Microsoft Azure, Blob Storage. We can go to a Veeam backup repository, and we can also go to NFS as well locally if that fits. But yeah, ultimately we can, if you're already an existing Kubernetes user with stateful workloads, push K10 in via the Helm chart. Once that comes up, go to the dashboard, you'll see all of your discovered applications dynamically, and then you can create a policy around that. We also leverage the underpinning snapshot first, and then we can export, or you can choose really whether you snapshot and export as the backup, or whether you just take the snapshot, or you have to do the snapshot and then export that out to a secondary location. So hopefully that helps. Is super simple is really what they've made.
Good. So I think related, I saw a few people ask about integration with Veeam software, and I can confirm that we do have customers that were Veeam customers and that decided to at least move part to start with of their infrastructure to Kubernetes, and they needed a backup solution for that. And we're very happy to see that Veeam actually does have with Kasten a Kubernetes backup solution. But then some of the questions were specific about integration. So maybe you want to shed a light on where we are and to what point it makes sense to be using a fully integrated product, since we're talking about different stacks really.
Yeah, that's a really good question. So today available is the ability to send your K10 backups to a Veeam backup server. There's some caveats in there that are all documented in the documentation, and that's kind of a version 1. So that's there today. It came out, I want to say, the back end of last year, alongside VBR 11A, and basically that gives us the ability to have that. So from a K10 perspective, we send our backups in. When you're inside Veeam backup and replication, that gives you the visibility of that backup. That's it. There is no recovery from there. As in, there's no recovery from VBR. You can still recover from K10, so you're not just backing up to a location. There's some really interesting stuff coming as a version 2 and around our platform services, if you're familiar with what we're doing there. But we've just got to wait a few more months until maybe Veeam on, until we can talk about like a more complete integration. There you go. That's all I can say without being fired. But to Tom's point as well, is that like there's a lot of us that will have some virtualization, some cloud, some physical, some applications that we need, and some Kubernetes. And I think this is important as a Veeam strategy overall, is that everything, the vision and strategy from a Veeam point of view is that we've made everything modular. So you have K10 on its own if you want, you have VBR on its own to manage your virtual environment, you have agents that protect your physical machines and endpoints, your servers and laptops. You have cloud products, Veeam backup for AWS, Veeam backup for Azure, Veeam backup for Google Cloud, and lots of other different point and modular solutions. So if you just have Kubernetes, then we've got you covered with K10. If you have a bit of everything and you want to centrally manage that, then we have Veeam backup and replication that allows for hook-ins or platform services to be able to hook in those modular approaches and be able to give you visibility of what each one is doing and be able to manage them, at least a way in which you can see them and manage them remotely. So I think it's all about, again, that the freedom of choice is a thing overarching Veeam. Being agnostic is a feature of Veeam overall. And I think Kasten K10 brings that from a Kubernetes and cloud native world. But yeah, hopefully that answers the question or questions.
Yes, someone was asking us if VeeamON is in person this year or still virtual, and I think we can share that it's going to be both, right? Or
yeah, it is going to be both. So May the 16th, this is the same week as KubeCon typically, so I've got to split myself in half to be in 2 different places. But yeah, it's going to be in person, but also virtual. We're going to have that hybrid approach to it.
Yeah. All right, cool. So another interesting question, and help me understand it as well, Michael. The question, I'm going to read it as it was written, was, can I leverage objects that aren't container in Kubernetes? And please give some examples. And I'm wondering if the person is asking whether we can protect other objects than just containers in Kubernetes.
Yeah. So yeah, objects is a broad term. So I'm going to so if we're talking about virtual machines, then no. However, we do have the ability when it comes to things like external objects, config maps that point to data services such as Amazon RDS. So being able to, your web front end might live in, or your application might live in Kubernetes, but your backend database might be leveraging AWS RDS as an object. It's then stored as a config map. We have the ability to capture all of that as part of our policy. And really, that comes down to that blueprint functionality that we have within Canister. Now, I would argue that you could look at that Canister blueprint and that formatting around that, and RDS is just a start of what that data service, that external data service that could be approached by that method. So hopefully I've answered that in the way is that, yeah, so from a let's talk like, so from an OpenShift point of view, OpenShift can have VMs and containers. We don't protect the VM side of things that are running on RHV. We do actually have something at Veeam that manages that, but casting K10 itself doesn't have that capability.
All right. And even though we're getting close to the end of the presentation, and let's not do a post game, we did a pre-game, we do one hour time, right? But I have a very detailed question here from Marco, and I'm gonna bear with me while I'm reading it. Given the technical challenges of cross-cluster migration of applications, are the transformations in custom K10 the only and manual way to adapt resources? Are you thinking about a more automated portability between different Kubernetes versions?
So we can automate that transformation piece. Like, we call it disaster recovery or automated disaster recovery. We could, in theory, create our own scheduled import policy that enables that to happen, that same transformation of whatever that needs to be. Maybe that's what we do next time, is we show some of this stuff.
That would be good. Someone was also asking a question about Canister and using Canister to backup managed SQL instances.
Okay, yeah. So I mentioned Postgres in there, but basically, yes. There's, if you where's the best place? If you actually go to docs.kasten.io, there is somewhere in the documentation there is a link to Canister blueprints or extending your protection with Canister. And there's a long list of stable releases that we've tried and tested out there in the wild that work. But basically, any NoSQL, so a number of NoSQL variants, but then also I've seen we're working on Microsoft SQL as well. So from a container point of view. Yeah.
And then maybe a last question, because it's also a good one, Bhagarath. Which format are my backups of in which format are my backups of stateful applications stored? Is it a proprietary Kasten format or a global open source format?
Oh, good question. I'm going to spin it ever so slightly. I believe that it is in a format that requires Kasten to open them, I believe, but let me find out. But to the point that, in fact, that the second QR code under K10, try Kasten K10, that gives you the ability to download and deploy Kasten K10 free, which will always give you the ability to open and restore those backups.
Yeah, awesome, great answer.
So hopefully that answers the question, but really good question. I need to find out.
And yeah, and of course you can't. Well, first of all, we can't know all the answers, and we could also not answer all of the answers. So we are going to follow up with a blog article or multiple blog articles for the questions that were not addressed in this. I see that the team answered at least 40 questions, so that's a bunch. I still see 7 open questions, so we have a few more that we need to address, but we're at the end of our webinar, and I would like to thank everybody for being here. This was a huge group. And then Michael, you definitely thank you so much for all the great content. Looking forward to the next webinar already.
Yeah, cheers, Tom. Thanks for keeping it real, and starting the pre-game.
Have a good one.